Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 24 of chapter 4 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.J. Craig, and J.N. Bolton. The statement of the problem is the 240-foot structure is used to provide various support services to launch vehicles prior to liftoff. In a test, a 10-ton weight is suspended from joint F and G with its weight equally divided between two joints. Determine the forces in members GJ and GI. What would be your path of joint analysis for members in the vertical tower such as AB or KL? So first that 10 tons is equally supported by joint F and joint G and need to find member force in GJ and then GI. The other one need to provide information that how to find member force in AB and in KL. So to start with, to find member forces in GI and GJ, it is possible to start with either method of joints or method of section, because by passing a section cutting IJ, IG, and GH, so it is possible to start solving it, and then for GI method of joint can be used. So this problem can be solved either by method of section or by method of joints. So I'm going to solve it using method of joints. Steps to find member forces using method of joints are: need to select a joint with at least one known force and two or less than unknown. So if I start with joint F, so joint F, at joint F, 5-ton load is acting, which is known because that 10-ton load is being supported by G and F joint. And then there are two unknown member forces. They are FJ and FG. So if I start with joint F, it is possible to find first FJ and FG, and then I can solve joint I, and then further I can solve joint G to find GI. Okay, so I'm going to start with joint F. So need to isolate the joint and draw free body diagram. Need to assume all unknown member forces in tension, and then need to apply conditions of equilibrium. So free body diagram of joint F is drawn. So at joint F, half of the load is acting, and then FJ and FG, they are assumed in tension, and then the triangle JFG is an isosceles triangle, okay, because JG is 10 and then GF is 10. So then both of angles GJF and GFJ, they are 45 degrees. So FJ angle with the horizontal is 45 degrees. So free body diagram of joint F and FJ is resolved into component FJY and FJX. So there is only one unknown in vertical direction. So I'm going to apply sigma Fy equal to 0 first. So applying sigma Fy equal to 0. So Fjy minus 5 is equal to 0 and Fj is equal to 5. And Fjy is Fj sine 45 and Fj comes as 5 over sine 45, which is plus 5 root 2. Then for sigma Fx, Fjx and Fg both are negative. So minus Fjx minus Fg is equal to 0. So Fg is equal to minus Fgx. Fgx is Fj cos 45. So Fj is 5 root 2 by substituting here and simplifying. Fg is minus 5. So now the interpretation of the signs: a positive value indicate tension and a negative value indicate compression. Because Fj is positive 5 root 2, so Fj is in tension, and FG is -5. So negative sign mean that it is compression. So FG is in 5 tons. So that is in compression now. So that are the answers for joint A. So now after joint F, I need to move to the adjacent joint J or G. At J, there are two member forces unknown, and at G, there are three unknown member forces. So I'm going to start with joint J. I need to isolate that joint J. So the free body diagram of joint J is drawn here, and there are two unknown GJ that is acting vertically downward, and then IJ that is an inclined member, so whose angle is unknown. So assuming that IJ makes an angle theta with the horizontal, and need to find that angle theta first. So by analyzing geometry, so the vertical sections each is at 20 foot. So on the left side, if I just isolate the cantilever part, so the side here it is 20 foot, and then 6 section at 15 foot. So then that total length is, that is 90. And then all triangles are similar because the height of each section is, vertical height of each section is keep on decreasing uniformly. So then if I find angle of whole of that upper cantilever part, so then each of that section is going to make same angle. So if I'm going to draw a triangle there, so and in that triangle, so its vertical side is 10 and the total is 15 times by 6. So then I can find that angle theta. That angle theta, so it opposite is 10 and adjacent is 15 times by 6. So tan theta can be written as 10 over 90 and theta is equal to 6.340. So now this theta is basically 6.340. So that is a free body diagram of joint J. Fj makes an angle 45, so it will have two components, Fjx and Fjy. And similarly, Ij, it has two components, Ijy and Ijx. So there is one unknown in horizontal direction, and there are two unknown in vertical direction. So first I'm going to apply sigma fx equal to 0, and sigma fx equal to 0 is minus Ijx plus Fjx. So minus Ijx plus Fjx is equal to 0. So Ijx is equal to, that is Fjx. So Ijx, this angle is theta. So Ij cosine 6.340 degrees, and Fj is 5 root 2. So then by simplifying, Ij is plus 5.0307. Then applying sigma Fy equal to 0. So Ijy is positive, Gj is negative, Fjy is negative. So then Gj is equal to Ijy minus Fjy. So now substituting the values of Ijy and Fjy, Gj comes as minus 4.4445. So then the sign of Ij is positive, so Ij is in tension and Gj is negative, so Gj is in compression. So these are the answers from joint J. So the next one, now Gj is calculated. So next I need to find Gi. And for Gi, I'm going to start with joint G, because at joint G there are two unknowns now. So I'm going to isolate joint G and going to draw its free body diagram. So for joint G, Gi and Gh, two unknowns, and rest Gj, Fg, and then a load at G. Half of the load is acting at G, so 5-ton load is known. But Gi angle is different from 45 degrees, because here In the triangle IJGF, both sides are 10. But for triangle IGH, now its horizontal side is 15 foot and the vertical side is more than 10 foot. So that is more than 10 foot. So need to now estimate what are the sides of first, what are the sides of I triangle IHG, and then need to find angle IGH. To find phi, I'm using previously drawn figure, but here the angle IGH is phi. So its horizontal length HG is equal to 15 foot, whereas its vertical is unknown. But left side of the cantilever is 20 foot and the right here is 10 foot. And then I can find out that how the values are decreasing. Assuming that from that horizontal and joint I, its distance is y. And angle theta is known, and then the horizontal distance from L to I horizontal distance is 5 section times by 15. So I can use tan theta, opposite y and adjacent is 15 times by 75. So tan theta previously calculated as 10 over 90. So y can be estimated as 25 over 3. So now DIH is equal to 20 minus y, which is 25 over 3. So DIH is 35 over 3. So now in the triangle IHG, HG is already known as 15 and then IH is 35 over 3. So then I can find tan phi is equal to opposite over adjacent. So opposite side is 35 over 3 and adjacent is 15. So phi is 37.875. So now once GI angle is calculated, phi, so then I can solve this joint. So now joint G, its component GI is resolved into components GIX and GIY. So there is only one unknown in vertical direction GIY. So then I can apply sigma Fy equal to 0. So sigma Fy equal to 0 is GIY, then GJ negative, then 5 turn negative. So then GI minus GJ minus 5 is equal to 0. So GIY is GJ plus 5. And then GIY is GI sine phi. And then GJ is 4.4445, substituting the values. And after simplifying, GI is plus 15.38434 because the answer is positive. So then GI is in tension. So GH is not required because only two GJ and GI are required. And GI is 15.38 ton, so which I have just calculated here, 15.38 ton. The other answer is GJ is 4.44 tons. So GJ is there 4.44 tons in compression. So both answers matches with the answer at the back of the book. So the next one is, next, what would be your path to joint analysis for members in the vertical tower such as AB or KL? So for KL, it is possible that to first for finding KL, so that section can be passed. But that section contain 1, 2, 3, 4 unknowns. It's not possible to solve it, but it is a possibility that I'll go here. So if I draw a section 1 here and just assuming right side, so on the right side loads are given and all dimensions are given, so then it is possible to find, let's say I am going to give that name as L dash. So it is possible to find K L dash using section 1, and then once done, so then it is possible to solve that joint too, because now if KL dash is known, it is possible to find KL now. So that is to find KL. And for AB, again, AB, so both of these sports are pin sports. So, and they have four reactions. So for those four reactions, these two sports make it statically indeterminate structure. Okay, but it is possible to solve it using method of joints. So if the section is passed there, a third section, and just considering the upper part, so then it is possible to find AB by taking moment about D. So other members A, B, and KL are possible to find using method of sections. Thank you very much for watching.